Okay. In that last video, we just finished to talk about what is force and what are the effects of force and what is balance and unbalanced force. Okay. Now, balance and unbalanced force. We just finished it. Then remember, force is a cause. Force makes the object to move. Then what causes motion is a force. Okay. Now here's a Galileo concept of motion. Now look here. Now consider there is no friction. Consider there is no friction. In Galileo concept, he neglects the friction. Because in reality, wherever we make the object to move, there is always a friction. But in this theory, he neglects the friction. Okay, now if this object from here, I'm holding it, then after I remove it, then okay, which action here is only gravity? There is only gravity, means force of gravity's action here. Then once I release my hand, then this object or this ball will roll till B. Then after, because when it reaches at this point, the speed are very high. Initially, the speed are 0, then after I release it, the speed will keep on increasing into what? Into gravity. Then once it reaches at this point, the velocity is very high, then that object again will move up. It will move up till it reaches at the same height as this. Now, if the height from here to here is h, then from here to here also will be h. Then this object, it will once it reaches at B, again it will move up till it reaches at point C, meaning at the same height as that initial. If there is no friction, if only gravity is acting. Okay, but what about this one? Now, if I release this ball from here up to point B, it move up. Look here. Now you see what's different here? This inclination, means this angle here or this angle here. Now this angle and this angle are the same. If the angle are the same, then this object will move at the same height. This height and this height should be the same. But here, this angle and this angle. Now if this angle is, okay, now this is smaller than one. Okay, now this angle is smaller than this angle. Now this angle here is smaller than this angle. Then in this case, this object will move. Okay, after it will run at a very high speed up to point D, again it will increasing the speed, then it starts to decrease the speed, but it will go to attain the same height. It will go to attain the same height. Now here also same height, here also same height. But where is the difference? Here the distance from here and the distance from here to here are the same. But here the distance from here and here are different. Now this distance is longer than x. When the angle is smaller, then this distance is longer. When the angle is smaller, then this distance is longer. Okay, when angle is smaller, distance is longer. Why is longer? If you just move up to here, will it reach the same height? No, it does not reach the same height. Then to reach the same height, it will travel a very longer distance, so that it can get same height. Because this height is always the same if there is no friction. That is just a theoretical, but in practical, in reality, this never happens. Because in reality, whenever this object will roll out, it won't reach up to this point. It will reach maybe up to this point, or this point, this point. Why? Because there is always a friction force. Friction force is the opposing force, which always hold this object back, which always pushing someone. When you push a box on the floor, it's very difficult for you to push. Why? Because there's a force which is pushing back. That is a friction. I mean, that is a reaction. Okay. Then from this theory or from this concept, we can conclude that as the angle is smaller, the distance traveled to the object is longer. Then from here, we can conclude that if we put this, okay, now this ball here, now this ashtray. Remember, if again there is no friction, then this ball will roll out, then it will travel forever. It will travel forever. Why travel forever? Because how much it travel also, it won't reach this height. We won't get the same height, right? Like here also we get the same height, here also we get the same height. Then if in this case, will it get the same height? No. Then it always travel forever. Means if there is no friction, according to this theoretical concept of Galileo. But in reality, if you roll a ball like this, at some times it will stop. Why? Because there's always some friction. Then this friction will be the unbalanced force. It will make the object to stop. Means it affect the state of object. But if in this case, balance force is 0. In this case, the balance force is 0. Then 0 unbalanced force will make the object to move uniform and uniform motion. 0 unbalanced force will make the object to move at uniform. If in this case, if there is no friction, then the balance force is 0, then the object will move forever with the same speed, and then it wants to attain the same height, but it never gets the same height, then it travels forever. But in reality, these things, it does not happen, because there is always a friction. Then that is the concept of Galileo. From this we can conclude that the object will move forever if there is no friction. Object will move forever if there is no external force. If object will move, it will move forever if there is no external force. What is external force here? Friction. Now this is a concept of Galileo motion. Then you can check it from your textbook also and read it. You don't need to read it by heart, just with the understanding. They won't ask you in exam. They won't ask you explain, or they won't ask you what is a. Okay, and this just to know the concept. What is Galileo? If the object will roll, it will try to attain the same height. Then it will move if there is no friction. But in reality, if the friction is always there, then it won't reach at the same height. It will be reduced at somewhere. Then return back to the point B. Okay. Then now after the concept of Galileo motion, then we come to Newton's. Okay, before we come to Newton, first I want to explain you about the inertia. Inertia. Okay, what's the meaning of inertia? Inert. Inert means unable to change. Unable to change. That's the meaning of inert. Then inertia means unable to change. When the object is unable to change suddenly. Okay, example. When you stand on a bus, if the bus starts suddenly, did it fall backward? Or if the bus is in motion, then you are standing without holding to anywhere, simply stand like this. And if the bus are in motion, then suddenly it stops, you will fall forward. Why? Because the body or the object, it is unable to change by itself. Once it is at rest, it wants to be at rest. Once it is in motion, they want to be in motion. Then, you sit on a moving bus. The bus are moving. Then you also move along with the bus. Or if you sit in a car also. If you sit in a car are moving, you also moving along with the car. And if the car suddenly breaks, then you will fall forward. Then you are accident with the driver's seat. Why is that case? Because your body is always in motion. They want to be in motion. You don't want to stop suddenly. That's why the body is inert. It's unable to change by itself suddenly. That is the meaning of inertia. The inertia means the tendency. It is the inability. What's inertia? The inability of a body to change. Inability means that it cannot do, unable to do. The inability of a body or object to change the state of rest or motion or direction. Look, when you sit on a bus or a car, if the car are moving like this, straight, in that direction, but if the car is turning like this, turning in this direction, then what happens to your body? Your body will fall like this. Why? Or if the car is moving in this direction, then you also moving in that direction, then in one direction alone, then suddenly the car is taking a turn like this, then you will fall like this side. Why? Because your body always want to move that direction. And that is mean the body is unable to change by itself suddenly. Then it always wants to move in that particular direction, in that particular motion, in that state of rest. Whatever it is, it will remain, it wants to remain there. That's meaning of inertia. And inertia means it is the inability of a body to change states of rest. It is the inability of a body to change its states of rest. It is the inability of a body to change its state of rest or uniform motion or direction by its own. Okay, should write by its own. It is the ability of body to change its state of rest or uniform motion or direction until. Okay, we'll change this. Until unbalanced force is acting. In by itself it cannot change. Then it has to be some force or some external agency to act on that so that it can be changed. Okay, that is inertia. Then there are three types of inertia. There's the one inertia of rest, number two, inertia of motion, and number three, inertia of direction. Okay, inertia of rest, inertia of motion, inertia of direction. Okay, what's that inertia of rest? Means it is the inability of a body to change its state of rest. It is the inability of a body to change its state of rest. That is inertia of rest. Then number two, inertia of motion. It is the inability of a body to change its state of motion. And number three, direction. It is the inability of a body to change state of direction. Okay, that you can study by your own from your textbook. I just explained what is the inertia of rest or inertia of motion, inertia of direction. Inertia of rest means the body is initially at rest. Okay, I'll give you an example. Okay. Now, look, this is a paper, now this is a lid, and both are resting on this book. Both are resting. Now, if I take this paper, flick it suddenly, now this object is at rest. And remember, this object is want to be remain at rest. Then let's see what happens. Look, will this object fall? No, because why this object is at rest and want to be at rest, then that's why it remains there. Look, but if I pull it very slowly, did this object stay there? It will go along with the paper. Got it? But if I just take suddenly, now this remains there. Because this object want to be at rest, now this is suddenly moving. Now that is the inertia of rest. Now inertia of motion means if this is in motion, but if it breaks suddenly, then this object will fall. Right? That is inertia of motion. Then inertia of direction. if already explained, if the car is moving in this direction and you also going along with that direction, then suddenly if the car take a turn, then you will fall back. Okay, that's inertia of direction. Okay, now I can give you a question. Apply the concept of inertia of rest, inertia of motion, and inertia of direction. Okay, why when you shake a tree suddenly, leaf fall down. Can you answer this question? Look, initially the tree is at rest, and together the leaf also is at rest. Okay, so there is no air. Only you are shaking that tree, maybe that tree that you can easily shake it, not a big tree that can shake. Now, example, if that is a tree at rest, you come and push it suddenly, you push it and shake it, then some leaves are fall down. Why? There's a reason, because of this. The tree and the leaf are both at rest. Then the branch of the tree also at rest. Then those branch which holds that leaf, when you move it suddenly, that branch of the tree also moves suddenly. Then but that leaf, because it's at rest, it wants to be at rest. Then if that branch of tree moves suddenly, that leaf doesn't want to move. Because I thought it's an inability of object to change its state of rest. Then, if that, okay, example, there's a leaf holding like this, then if this branch moves suddenly, then the leaf will fall down. Because there's no more to hold that leaf. Okay. Why when you shake a tree suddenly, the leaf are fall down? Got it? Because why it's fall down? Due to inertia of rest. When the tree and the branch are moved suddenly, then the leaf doesn't want to move, then it detaches out from the branch of that tree, then the leaf falls down. Got it? Then there are so many types of questions like this in your textbook. Okay, then if one more question. One more question? Okay. Why when you stand on a moving bus without holding? You stand on a moving bus without holding, if the bus stops suddenly, then you fall backward. Why? That also it is due to inertia of motion. Because you are in motion, then if the bus stops suddenly, then you don't want to stop, then your body is moving forward. Then but your leg are attached to the ground of that bus, then your leg stop, but your body does not stop. Then you fall forward. Okay. Now you got the meaning of inertia and you got the meaning of concept of Galileo. Then we'll come to, okay, now don't forget this, what is inertia and what are the three laws of inertia: laws of inertia of rest, inertia of motion, inertia of direction. Okay, and one more, remember this, these are very important. Note, inertia for a larger body and a smaller body. Remember, inertia is the measure of mass. Remember that inertia is the measure of mass. Whenever the mass is more, then the inertia also will be more. Okay. More is the mass, more is the mass, then more is the mass, then more is the inertia. Remember, inertia is mostly talking about mass, meaning the inability of a mass to change the state of rest, or to change the state of motion, or to change the state of gravity. Okay, when more is the mass, when the mass is greater, then the inertia also is greater. When the mass is smaller, then the inertia also is smaller. Okay, I'll give you one question. Then this you can, I won't give the answer for this. You can answer it and send it to me. Okay. Question. The bus and the car. The bus and the car are both moving with same speed. Both moving with same speed. Which one has more inertia? Which one has more inertia? The bus and car are both moving the same speed. So stop. Which one has more inertia? Okay, you answer this question. Not either the bus or car having both inertia. I don't know, but you have to give me a reason. If you said bus has more inertia, you have to tell me the reason why. If you said car has more inertia, you have to tell me why car has more inertia. Okay. Then this will be a question for you, and you try it and write the answer and send it to me. Okay, for this question is already there in your textbook, then you can easily read it, but don't just simply read and by hand and mock it. Please read it with understanding why that things has happened. Okay. Okay, and thank you for this topic. And I'll continue the next topic about Newton law of motion in next video. Okay.